Okay, guys. I just give a very quick response to all the answer of all questions. So the first question is, please provide at least 3 of the sensor and based on the corresponding potential failure mode of the deep excavation. So maybe you all know that the lateral earth pressure will be in one of the failure mode. And the other one is what we call the piping, okay, based on the very high water pressure. So you need to think about it, how to choose the appropriate sensor at the appropriate location with the potential failure mode, okay? But I think this is very good for most of you for the first questions. Okay, and please introduce the vibrating wire sensor and its application. I think most of you give a very well introduction of the vibrating wire sensor, but maybe some of you misunderstanding the vibrating wire just using the natural frequency that affect maybe by the displacement or the strength, not the vibration sensor. Okay, this is a different. Okay, so the vibrating wire sensor can be used as a strain gauge. Okay, so you can measure the displacement, the pressure, and anything else. Most of the sensor we can use with the vibrating wire sensor. Okay, so what is the INSAR? This is a radar image from the satellite. So you can check out the radar image by the refraction to the satellite. And this refraction will be used for maybe the surface displacement or the what we call the settlement. Okay, if you can use the difference between the 2 images in a different time, so you can check out the difference from the wavelength. Okay, so you can check out how much of the displacement it is in the ground surface. Okay. For the fourth questions, so this is the Earth stand, actually the real data. One is in the upstream, one is in the other the left side, right side. So this is depend the different direction. But I would like to say, for somehow you can find this is a trend tower to the left side totally. So means that something that our inclinometer is not fixed very well in the end. Okay, so that may be one of the major problem. And the second one, you can find there's some data not so move in a same pattern, maybe a little bit random. So maybe this is from the noise or from the uncertainty of the inclinometer. Okay, there will be a second problem. And the third one, you can find this a little bit S-shape. Okay, so one reason maybe from the not ground very well that between the spacing of the inclinometer pipe and the borehole. Okay, and the other one is that because this is a dam, earth dam. So when we have the settlement of the earth dam, so actually the ABS pipe will have the S shape because of the compression behavior. Okay, so if you have already mentioned some of this, you can get the score. And for the next questions, I think the first one here. This is the X is the water level of the reservoir, and the vertical one is the groundwater pressure, groundwater level. So you can just use the linear regression to get the value to quantify the variation and give some of the boundary with maybe the standard deviation. Okay, so this is a very easy But for the second case, this is also the reservoir water level versus the leakage, or the volume of the leakage. So you can find here with a lot of data. So in the last time we say that may include the dry season and the raining season. Okay, so here this is the mean value for the maybe the polynomial regression. Okay, but you can find this envelope because of the rainfall effect. We have a lot of the bias of the leakage. Okay, so you need to mention that, and to some of you already show that the problem. Okay, and for the sixth, I think most of you did not finish these questions. Let me choose the example for all of you. I think the first S1 is very easy. You can find maybe the three component in a high frequency level. Whoa, whoa, whoa. What's the problem? Okay. My old computer, please. Take a while to open the MATLAB. And don't forget, please check your homework that already received the scores or not. Oh, okay. Because I think in our class, the performance and the homework will have a very big percentage. Okay. Oh. Why? Before I study the MATLAB, let us talk about the final questions. Okay, I would like to say, oh, okay, here. Okay, I would like to say for these questions, I would like to ask to monitoring the electrical power tower, the truss type behavior. And I already know that the vibration due to the maybe wind or some earthquake is more than 40 hertz. So I need two accelerometer with the 3 axis. So right now I need 6 channel, right? And the 1 channel for the maybe some of the what is that? The strength. Okay, so I need a 7 channel for the monitoring. And actually, for this 5 device, actually provide at least the 8 channel, okay, for the monitoring. But somehow you need to find out. In the last time we said there's a different kind of the measurement. So you can use the differential of the measurement or some of the single channel. So depends on your the requirement of the accuracy. So all of this can provide at least 8 channels data acquisition. But somehow you need to check out. In the last time we said we need to concern the Nyquist frequency. So the lowest frequency is the 80 hertz. But somehow in the practice, we need 10 times of the behavior. So maybe we need up to the 400 hertz. Okay, so I don't know, maybe Adam, it is not so good because I think it is only maybe 100 hertz of the sampling hertz frequency. And CR 1000X, I forgot, maybe up to the 5 or the 500, maybe, okay. But for the C, D, and the E, maybe up to the 1K to 10K hertz. So it is much faster sampling frequency for all. So you need to choose by yourself. And the last thing is that only one does not need the computer. It is the CR1000X. So you can program with some of the software we call the local net. So you can upload just like the Arduino. It can operate by itself. And the others, Atom, NI, PSCI, USB. 4 of this device need another PC for the embedded system to control. Okay, so you need to answer that your decision. Okay, so for okay, I just very quickly show oops. Okay, here, this is the first one, waveform. So actually, I combined 3 of the signal here. 350, and maybe this is the, I forgot, 480. And this one is 485. So you need to show up the spectrum first. But if it is just only 500 hertz, I mean the downsampling, so only I can see is up to the 250. So maybe this, well, cannot be seen anymore. Cannot be seen anymore. So this is the problem of the downsampling. Okay, another one is the truncation. Here, I truncate only to the 1/8 length of the original one. So after the truncation, you can find here, this is a truncation effect. So for the first, this, maybe I can still find the maybe around the 350 hertz components. But however, you can find I cannot distinguish from the very close component. One is 480 and the other one is 485. Because of the truncation, I lose the resolution in the frequency domain, right? So that's why I cannot distinguish from the very close spectrum anymore. Okay. So let us to find the second one, the S2. Okay, the same. I just show very quickly. So this is the shape of the S2. So you can find this is a very low frequency component actually. So here, I just put, maybe I need to enlarge. Okay, one is the 2 hertz, another one is a 5 hertz component. But however, you can find here, I put a little bit high frequency noise, about the 250 hertz noise in this signal. So you can actually, you can find this is the very low frequency pattern, but however, you can find a little bit noise. Okay. And of course, if I have the truncation, this is a truncation. Only 1/8 of the truncation. So here you can find, because of the low resolution in the frequency domain, so I can find the difference between 2 hertz and 5 hertz because there's the mixing because of the low resolution in the frequency domain. Okay, I think you can understand right now. So in the third problem, if you already find the, I just show that this high frequency noise. Oh, if you already found maybe this is 250, so you can set up a low pass filter, and the criteria is maybe smaller than the 250 hertz filter. Okay, so this is the answer for all the questions. Any problem? Yes.
I want to ask first, how do we know the maximum sampling rate of the DLQ? I mean the maximum capacity of the.
You mean the device?
Yes.
Any device already lists the spec, the specification of the sampling rate. Okay, so that's why for that 5 device, I need to list maybe 3R, rate, range, and the resolution. So for the rate, you already know that the sampling, the maximum sampling rate. So maybe for the add-on, there's only maximum 100 hertz of the sampling frequency. So means that maybe in practice, only you can monitoring the 10 hertz of the vibration actually.
Then somehow I see there is like 10 TS per second. But
10
TS.
10 TS.
Yes, I don't know what.
TS.
KS.
KS. Yes. K is mean the 1000.
Okay.
1000. Yes.
Per second.
For example, 10K means like the 10,000 hertz. Okay. Okay.
In this case, what the unit of the amplitude?
Amplitude.
Yeah.
You mean this one?
Amplitude. Yes.
Amplitude.
Yeah. You have one figure, right? Amplitude and time.
Which one? This one?
Yes.
This one?
Yeah. Amplitude. Y-axis.
Amplitude, right?
Yeah.
Actually, this may be voltage. Yeah, maybe the voltage. Yes. Is there any questions? No? Okay. So after the midterm exam means that you need work harder in the final project, right? Okay, do your best. Okay, show what you can do. So I would like to remind all of you again for the final project. Okay, so I think one group already put the sensor in the field, right? But the other 3 groups maybe you can find this only 2 boxes over there. But maybe in these few days, I will ask the rig to install the third one box with the sonar panel. Okay. So please keep yourself when you try to install the sensor in the field, and please ask rig first. Okay, for help if you try to go into the field and install the sensor. Okay, don't go there by yourself. Okay, if you try to go to the top of the slope. Okay, a little bit dangerous. Okay, and second one, that please confirm that all your system should be very durable. I mean, all the wire, all the sensor should be fixed very well. Okay, because we put the system outside, and you already find just the very small rainy day in Taiwan. Okay, if you have a chance, you can see the very strong wind blowing during the typhoon event. So all the wires, all the sensor, all the cable will be affected. So you need to fix. So I would suggest that if you need a sensor outside of the box, for example, you need to check out the soil moisture. Make sure that your cable fits very well. And I would like to install that a PVC pipe protect, and you can through the cable into the PVC pipe and attach to the steel, big steel pipe with the tape or the some of the fixer. Okay. And also please confirm that, because right now we already provided the solar panel, and just now I already checked, we forgot to remove the plastic cover of the solar panel, so please remove that.
And we need also new cables because it's USB-C.
Yes.
So we need to adapter or something to the cable to for the power supply is
with a USB, right, cable. Yeah.
We need the USB-C for the battery.
You mean I give you the battery with a USB-C? Yeah. Oh, so yes, you can buy the adapter or the cable with a different terminal. Okay, but make sure also the cable of the solar panel should be fixed very well. Okay, because in the last time I already checked one of the solar panel, the cable already broken. Okay. And the third one, because you already have the box, so I would like to, I already asked all of you to have installed the accelerometer with the 3 axes, X, Y, and the Z. So you need to make sure that your sensor is fixed, maybe fix it at this area. And you need to make sure that maybe this is for the X, I mean to the screen, okay, to the screen, and this is the Y, and the vertical is the Z direction, Z direction. So make sure that. And supposedly, because I would like to encourage you to think about how to integrate with the SD card. But I know that it is a little bit difficult when you put so many sensors together and with a limited of the pin and the channel. But I would like to say, for in the practice, actually we may lose some of the data if I use the maybe no matter the LoRa or some of the 4G modules, still maybe I will miss some of the data. But if you have the SD card in the field, I would like to say the SD card will, I mean, totally save your data, okay, except the power consumption problem. But mostly we can avoid the problem of the transmission data with the wireless technology, okay? Because from my review, maybe 80 to 90% of the success of the transmission is good enough. It's good enough. But if you can, if you find some of the missing of the data, maybe you can restore with the data from the SD card. Maybe it will be much better, okay, to compare I mean the durability of your system and also the wireless transmission. Okay, so please think about it. And oh, the first, in the last time we already show you how to use the LoRa to capture let me show you the LoRa CMP. However, you need, for your practice, you need a computer or laptop to open the LoRa, maybe very long time to capture the because you need to open the service always. And let us to check out okay. So in the last time, we already have a very good practice. But in the last time, I just have a type error here. But actually, you can find I already upload the data to the ThinkSpeak. Okay, so I already show you on the line. But if you try to 24 hours capture the data from the MQTT and send it to the ThinkSpeak, means that you need to open your computer 24 hours a day. But I would like to say, if you already compile, already program, you can use my lab computer. Okay, I mean, each group can have your own flow. The flow one for the first group, second one, third one, and the fourth one. Okay, so you can processing the capture the signal from the MQTT simultaneously. Okay, so let me check. In the last time, I already upload to the ThinkSpeak. Okay, this is last week. I already show you with the synthetic data. Okay, you can find here I already checked out. This is Friday, May 22, from the 11:30 to the maybe 12:15. Okay. Of course, this is one of the option. You can upload the data to the ThinkSpeak. And maybe you can think about another approach to find some other example using the Node-RED to transport the data to your database. If you try to have some of the very solid, because this ThinkSpeak is free, so means that only limited data can be uploaded. So you can think about how to upload to your own database, where you can show a very good website, because right now I think it's very easy to generate a website, and also with this kind of little plot, okay, to show your data. Okay, you can think by yourself and discuss with your team members. Okay. Okay, before I start the next chapter, okay, regarding the wireless and IT, here, in the next week, we will have a very quick practice based on the Raspberry. So each group, I borrow you a Raspberry, so you need to go back to install the OS by yourself. Okay, this is an adapter of the HDMI, because I buy the fourth generation of the Raspberry for you, because in the next week, we will have a very quick practice of using the camera integrated with the Raspberry, but it's just a practice, okay? Because maybe it is not so I still check out the performance. I try to put this device maybe in the view, okay, for the vision monitoring. Okay, so each groups, you need to take one of this and one of the adapter, okay, and one of because right now the fourth generation using mini HDMI, so if you try to change to the original HDMI, you need this adapter, okay. Okay. But I would like to say, please go back and install the OS by yourself. Because you need to use the maybe environment with the wireless Wi-Fi, with the Wi-Fi. I install that. And I would like to say, I have already have my. I don't have the BNC. If this is okay, maybe we have a very quick 5-minute break. 5-minute break. You can check out by yourself, and you can discuss the final project with your team members. Okay, let us have a very quick 5-minute break. 我们休息5分钟一下。